Hello, how are you all? Today we are going to write the program in the MATLAB software. First of all, we are going to write the program for the step signal plot. How we can plot the step signal if it's a discrete type. So here we go. First of all, we will select the new script. After that, we will start writing the code, and the code is overall bit related to um, first of all taking the value n from input keyword, and that will be provided by us in the command window. And then after that, considering a variable t, where we will tell uh, the value on the x-axis, we put the n, so that the n value will be vary from where to where. It's vary from 0 to n minus 1, 0 1 or then n minus 1. Okay, so in this way we will write, and here you can see below that it in the input statement is showing what's that do and how it should be write everything. Okay, so now let's move further. After defining the n, and by defining the n value from where to where it should be vary, after that we will write the how the step signal need to be. Okay, it's mathematical function. So for that mathematical function representation, we will use a variable y and use once and once keyword with the statement that the one value should be vary from 1 to n. Okay, then we will use temp statement, and it will basically used to plot the discrete signal. And after that temp statement, writing that, we can move further on the we need to show we are going to represent that signal in the plotting, or it should be in plot that way. But what's the labeling of the, as it's a 2D design, so what's the labeling on the x-axis and the y-axis? So now further on we will write the x labeling and the y labeling. We will do that, and basically we will write for the y labeling is a magnitude, or we can say amplitude, and for the similarly for the y labeling also we will write for both of them. Okay, so let's do this. Y labeling amplitude, further on the x labeling we will label it n. Okay, and then we will run it with, first we will save it, then we will run it. Okay, so let's do this. Some signals for basically for plotting, y labeling for y-axis, x labeling for the x labeling, x-axis labeling. Okay, so it's done. We run the program and we are getting our waveform. As we have written, our enter number is equal to n value is equal to 8, so it's showing the n value from 0 to 7 for the 8. And now we will take another program. This program basically what it will do. Okay, so this one basically used for correlation or cross correlation or simple form. We just need to write the take the two input sequence x and z, and then we need to do the cross correlation. Though for that we will use XCOR, and then brackets. In the bracket we will put up the our input variables x and z, whatever we will take. Okay, and after doing that mathematical, we will do that function need to be plot. For that we will use stem, and further that will be display, disp we will use for displaying down that in our command window. For display will be in the command window basically, and the stem or the plot for the figure, showing in the figure. So further we will do the labeling for the X labeling, Y labeling, and you can also do the title also. So let's do that. Complete the code, check it out. Also you can check your each keyword or the code type, inputs, stem, X labeling, Y labeling, every all that statements you can check in the MATLAB code. It's available there. Okay, just need to whenever you type, before typing it completely, it will show you. That way it will show you there what it's do, what's how it need to be right. All that information will be in the below bar in your MATLAB or in the online MATLAB. And also you can check the MATLAB code, or you can check the question answer session from where you can know the query, certain type of queries, or you can type your question and the maybe someone in the expert that will tell you. Okay, so let's complete it. Done. Okay, so here we go. 2 lines more. X labeling, then Y labeling. Okay, let's do this. It's kind of interesting thing. Yeah, it's surely much interesting thing to do. The codes, write the code, and it's not easy to find the right code correctly on the internet sometimes. So just use your little mind and the MATLAB help, MATLAB code help. You can write. Now let's run it. Let's save it. I just say correlation, cross correlation. We will type correlation. Okay, so here it's, let's save it. Done. Okay, now we will enter the sequence after running, after run command. We will take the first sequence 1 2 3 4, and the next 1 2 3 4 5 first sequence, second sequence 6 7 8 9 10. So after typing both and entering, we will get our output display. In the command window also we will get our figure. Okay, in the figure. Okay, so it's done. Let's move to the next DFT. Okay, DFT is basically discrete Fourier transform. What's the code basically uses the FFT basically keyword. Okay, so let's move to the next code. It's like a great enjoyment type. So new script, now close the other scripts. So let's move. Let's type complete program. It's an easy program. First we will declare the input, and the input will be taken from inside only. We don't put up that the way. We will consider our n value on the x-axis. It will be, so it will vary from where to where. And then further on we will check our x input, and then we will do the absolute function. Okay, so let's do it. And after performing the absolute function, we will move to the next. Let's say we will get the real part of the complex magnitude, and after that we will calculate our angle value. After calculating angle, we will calculate our f, and then further on we will plot both values, and we will set up the x-axis in the magnitude and the phase, both plots, how it need to be done, and how the subplot is used for plotting the both graphs of the waveform in the same page and same figure. So here we go. Let's so type it. It's a last program of this one, this video. Further programs also added will be added in this channel only. You can check out those videos also for your lab helps. And if you are new to the MATLAB and you need to do certain simple programs, you can also check them also, for if you are in the research area, and if you are in the bachelor's, master's, wherever you are, it will help you in a hardware way. If in um, this subject is taught in the diploma also, then also you can prefer this FFT. Here we do our, for representing our DFT signal, we will use FFT. Okay, let's do this, complete the code, and then we will run it. If the XF value is too much low for what it need to be, then also we will write this statement. And values it should be less than this particular value, then it should be 0. And after that, analyze the magnitude part. Mathematical portion is done. Now we will do the angle portion, imaginary, you can say in the other language. So the length statement here, that's basically show the number of discretes function in your one of the signal. So the length, such as you have the 1 2 3 4 5, and then you have this sequence 1 2 3 4 5, and you have this sequence. So there are the 5 numbers. That's what basically length will find out. After that we will do the subplot statement. Okay, let's do this. So but to complete, we give the title for our real part of the magnitude part of the magnitude, and then we will give title to our phase part. We can also give the X labeling and Y labeling, but that's your choice, but I'm not giving. So now we will copy from the line 11 to the 15. paste. So let's do the changes need to do for the phase plotting option. So we have completed just phase. Write down the title and the plot for the phase angle will be present in the degree form. Now let's run it, save it. First of all, we will save it and run it. Okay, now we will have, sorry, there's a certain errors in my work. It's due to I used somewhere the uppercase, but the MATLAB is basically overall in the lowercase, or the define the keywords are used. That should be in the lower case only. So let's correct all the parts, just like pi. For the pi, P is capital. For the angle, A is capital. That type of mistakes. Let's hmm, there's a few errors here. Just like skip a few letters. let's correct it, then we will run it. So here is, after running it, here is a output window for the magnitude and the phase for the particular axis, whatever we need to be show. Okay, so if you need any program on any other software in the electronics field, then you can type in the comments and tell this one, and I will upload the video for that particular program for the particular software. If it's belong to this field or the research area of the electronics area, I will do that. That's all for the today. So you can check this code again if you are unable to understand somewhere, and ask. Okay, so that's done. 3 chords completed today. Sweat out. Here we go. That's the best thing we had done. Lights. So it's the end. Or you can also change the value of the x, so sine to a pi ft, their present x value. You can change the f value 10 to any other, 30 to 40, any other, whatever you want to. It's possible. After changing these values also, you can check if there is a change in your figure or not, or if it's same. You can check. Here you can check. It's same, almost same, little bit difference. You can know the difference if you clearly check it out properly. Okay, that's all for today. Thank you.